Okay, today we will have talk on radio frequency energy harvesting. This is a burning topic. So far, we have seen that we can harvest energy from environment using solar, using wind, and there are various other means. The topic has been inspired from rural as well as hilly areas because they are facing problem to have power supply. Lot of uninterrupted power supply problem is there in rural area, specifically in Bihar as well as in Uttarakhand. The power supply is not stable. So we thought of to resolve that problem by our research group. So our research group is working on RF energy harvesting. This RF energy harvesting can be achieved using antenna or using absorber. Antenna has been developed since long back, but for this energy RF harvesting applications, specific sort of antennas are being developed, and we are using array as well as dielectric resonator antennas to harvest RF energy with some sort of efficient rectifiers being integrated with these dielectric resonator antennas. We have seen that self-sustainable IoTs will come up for smart cities and for smart homes. Even for DC homes, this concept of energy harvesting application will be a beautiful concept. How we are going to achieve this? Already in the market, Schottky diodes at microwave frequencies are available commercially. We thought of to integrate or making use of these Schottky diodes as rectifier in place of the DC rectifiers. The We tried to have the ambient RF radio waves available. There are certain frequencies where already the radio waves are there in the environment, such as 2.4 gigas, which is being used widely for Bluetooth and Wi-Fi applications. 1.56 gigahertz is another frequency where the GPS systems are being operated. Even with this concept, the drone battery life can be extended by using radio waves. We will talk about how can we extend life of drone or operationality of drone flying hours by having this concept, because nowadays IoT and drones are in the use of society in various applications. Uh, to resolve this issue of drone operationality hours extension, and as well as where there is no power supply available, uh, we want to crack that particular problem. And this problem, the solution will fetch us the power supply even in the smallest village without having any battery and conventional power. They will be able to have the lamp light for their children study, even if there is no battery with them and there is no conventional power supply or electricity is available to them. And the third advantage will be even the solar cells are depending on the availability of the sun, whereas this RF energy harvesting don't require any sun, only radio waves are there, and almost every place the tremendous amount of radio waves are already available. So we want to harvest, we want to use those radio waves available in the environment, and with the help of antenna we'll capture them. With the integration of Schottky diode, we will rectify the AC available voltage to the IoT, and IoT or small devices will operate without the need of battery as well as electricity. So the concept is very beautiful or very innovative. Only the thing is that the device, our device will be able to produce only low voltage. But nowadays there are certain means available that low voltage can be converted with the help of voltage doubler or voltage quadruple circuits, electric circuits. Again, while developing this voltage developer and quadruple circuit, we have seen that the diodes itself offer a certain amount of loss. Then we have thought of to go one step further by making use of CMOS, the current technology, which is very efficient and can replace these Schottky diode with transistors, P and N and type of transistor combination that can be used to develop rectifier circuits. So in this scenario, the loss which is being offered by rectifier circuit developed by the diodes or Schottky diodes can be minimized to another extent. So coming back to the original solution of capturing radio waves at particle frequency, we thought of to capture 2.4 gigahertz, that is Wi-Fi frequency, and 1.56 gigahertz, that is GPS, which is available freely at every corner of the environment. We will capture these RF waves with the help of dielectric resonator antennas, maybe in multi-mode operations, and then with the help of combiner, the combined output will be given to the rectifier, and in specific the CMOS rectifier. The CMOS rectifier will be further developed in configuration of voltage developer or voltage quadrupler, so that the efficiency of rectifier will enhance manifold. Like this, we can produce up to 1 volt with a certain milliampere of current, as well as up to we can go ahead with 5 volt and a few milliampere of currents. With this production of RF energy, we will be able to operate our smart IoT devices, maybe for the application of smart city, maybe for smart homes, and maybe for rural applications. This is all for today's lecture. Thank you.